Okay, my little geometries. Madeline, Mia, and Gage. All right, this is geometry. It's 8.1, page 344. We're starting on circles and chords. Circles and chords. This first lesson is going to be a lot of definitions, what things are. So number one, this is a circle. This is the center of the circle. The center of the circle is from the center of the circle to the outside of the circle. That's called a radius. All the radii inside of the same circle are equal in length. Okay, if I have another line that goes from the circle through the center, wow, that got really bad. Sorry about that, Madeline. This goes from the circle to the circle through the center. This is called a diameter. This is a diameter. This is a diameter. This little puppy here is a radius. All right. We have another one here that just goes from the circle to the circle, not necessarily through the center. If it goes anywhere from the circle to the circle, that is called a chord. Okay, C-O-R-D, a chord. A diameter is a chord, but a chord is not necessarily a diameter. A chord just goes from circle to circle. A diameter goes from circle to circle. It also goes through the center. Okay, half of the diameter is a radius. Okay, so we have all these words. You got radius, diameter, and chord. All right. So we got radius. Today it has an H in it. Just a minute ago it didn't. How do you want to do that? I don't care. Is it a chord or a chord? Let's see. CH. It's a chord. Like it could be a G. It might be an A flat chord. I don't know. Anyway, so we have first chord postulate. If a line intersects the interior of a circle, it contains a chord of a circle. So if a line intersects the interior of a circle. So if I have a circle, what they're saying is this. If a line goes through this circle, anywhere, this part right here is a chord. If a line passes through the circle, it contains a chord of the circle. That's all that's saying. All right? Next theorem. Let's go to a different color here. I like blue. All right. Next one here says, if a radius is perpendicular to a chord of a circle, it bisects the chord. So, we have a circle. Center. There's a radius. It says, if this radius bisects, I think it says, no. If a radius is perpendicular to a chord. So if there's a chord that passes through this radius, like right here. If this is 90 degrees, that's not exactly 90 degrees, just tweak it this way. But if this chord is perpendicular to this radius, then this radius bisects that chord. If I have a radius of a circle and a chord is perpendicular to it, 90 degrees, then the chord is bisected by the radius, and we can do stuff with that, all right? Okay. Cool stuff here. Next one says, if a radius bisects a chord, okay. It says if I have a radius, and there is a chord right here, and this radius bisects the chord, then it's perpendicular to it. Okay? That's going backwards from the other one. It says if a line in the plane of a circle that is a perpendicular bisector of a chord, all right, the line that is in the plane of a circle that is a perpendicular bisector of a chord contains the center of the circle. All right, let's see if we can do that one, all right? So here's what we got going. We have a circle. Here's the center. It says I have a line, and what is this line going to do? This line is in the plane of the circle, and it's a perpendicular bisector of a chord. If the line in the plane of the circle, that is a perpendicular bisector of a chord. So what we have here is we have a chord. It's a G chord, okay? And this is a not good circle, but you're going to accept it because you don't have any choice, and you have to. If I had Madeline here to draw my circles, it would go much better. What this is saying is, if a line is perpendicular to this chord, not only that, if it's a perpendicular bisector to this chord. So if this is the center of the chord, okay, and I have a line that is a perpendicular bisector to it, it will also go through the center of this circle, okay? We're going to move the center of the circle so this works, because my circle is like not right. But if I have a chord and I have a perpendicular bisector to it, this line will go through the center of the circle. No choices, okay? So we got it going all three ways. So if we have a circle and we have a radius, and it has and a chord is perpendicular to it, the chord is bisected. All right? So if I have a chord and I have a radius that bisects it, it is also perpendicular. All right? And if I have, let's see if we can do this, who knows? If I have a chord, this is the one I have trouble with right here. So if I have a chord and I have a line that is the perpendicular bisector of this thing, it goes through, ta-da, if it's a perpendicular bisector of the chord, it will go through the center of the circle. I did it. That's all three of them. Wow. Praise the Lord. Thank you very much. You can pay me later for those, okay? Because that was like so fun. Last one here says, in congruent circles, or the same circle, two chords are congruent if and only if they are equal distance from their centers. Okay, so this one here, we have a circle. It says two chords are congruent. So this chord here and this chord here are the same length. They're congruent. That's true if and only if this chord is this, if this distance here and this distance here are the same. If this distance from the center to the chord and the center to the chord, if those distances are the same, then the chords are congruent. If the chords are congruent, then these distances will be the same from the chord here. And it's always going to be at 90 degrees here. And I don't know if you're seeing this or not, but it's making all sorts of cool things. Triangles, right triangles, all sorts of stuff that we can do things with because we know stuff about it. You understand? That is all this stuff is here is true. These two pieces here, these two pieces here. We have lots of stuff we can do with this, okay? These two pieces right here. So that's what you're going to do, is you're going to do things with this stuff. Okay, I've got you down there for what you need to do. On 4 through 9, you understand there are no numbers. So it's just letters. Like on number 8, want to know what the length of B to E is? Okay, so what you do know is you have a right triangle. You have X and Y. Do you see that? Those distances. So that triangle there, okay, so that triangle, what you have there would be x squared plus y squared, and take the square root of that, okay, because that is the radius of the circle, AO. Hope you see that. That is that distance. And if you multiply that distance by 2, that is how long it is from B to E. Okay? Put that in your brain. Think about it a little bit. It's a right triangle. Because, see, watch this. The length of AD is the same as Y. I just flipped it over on the other side. So we have a right triangle that is ADO. And the hypotenuse AO is the radius of the circle. So AB is also a radius of the circle. So BE is 2 times that radius. So twice the length of the hypotenuse is the length of BE. But there's no numbers, there's just letters. So have much fun with this, okay?